Yeah. Actually, this water bed a little bit contaminated.
Yeah. A little bit?
A little bit.
Not a lot.
I don't know. I haven't used that survey to test this yet. But. So now she's checking her flow. Looks like she's really careful about those things. So her glove is not contaminated, which is good. Look at her smell on her face. So Matilda, do you want to time this?
Yes, I will. Like whatever I see in the clock after I remove gloves, I'll do -1.
Alright.
And I also want to check.
So you can hear the same frequencies per each tube. That means it's pretty good. So everything's equal.
No.
Okay, Nella, are you running PCR?
No.
Okay.
All yours, Amanda.
Okay, very much.
Alright, so now everybody's in the video now.
What? Yes. I know I shouldn't be, but I didn't think ahead of time that I would be working. With the US. So I'm just going to ignore.
Safety officer.
What?
Safety officer. Safety.
Sorry.
Okay, I work one off.
Are you doing work, Stephanie?
What?
Are you doing work?
Yes.
Okay.
Of course I am.
Good.
I'm always doing work.
Alright.
I can tell you what we did so that it would be easier to put it in perspective. So we have this LSU RNA, which is called as large subunit RNA, and we have it from two species. One is Aspergillus nigricans, which is kind of a control because Paul has been doing experiments with this for a long time now. And one is Aspergillus fumigatus, because it's a pathogen and we are mostly interested in that. So we are dealing with both these fungus and the LSU RNA from them. We had a construct in which we had a promoter, E7 promoter in front of this intron RNA, and then we transcribed it. So while transcription, we made use of P32 label UTP. So what we got at the end, what RNA we got at the end was radio labeled. So this is the RNA, which is hot. Now, since it's an intron RNA and it's a group 1 intron, it's expected to self-splice, but it's hypothesized that these are not the self-splicing introns and they need protein for splicing, so we are going to check that. So what we are doing is we have these splicing buffers, which are mostly the combination of MgCl2 and DSCF in different concentrations. So we have splicing buffer 1 and 2. So we have two splicing conditions that we are going to use. We have made a 5S stop of these splicing buffers and we are trying to make a splicing reaction which is 20 microliter. So we have the splicing buffer, we have the RNA, of course. Depending on whether it's a protein dependent splicing that we are checking or it's just the RNA alone, we are going to omit or have protein in the reaction. Apart from that, we have MgCl2 GTP which is a 50 millimolar concentration, and we need a final of 1 millimolar, and then H2O. So since it's a 20 microliter reaction and this is 5x, so we have 4 microliter of this. Whenever we have protein, we have 1 microliter of protein or nothing, and then we have 0.5 microliter of this. We have no water since our RNA concentration is really